Today we're going to be looking at For Loop Notes 2, which I sent you in an email. We're going to be going into details of the for loop, how it works, why would we use for loops. So let's work through this code. So I've got a bunch of comments here at the start. So initial question is, why would we use loops? And the reason we use loops is because at times there are points when we want to have the code to repeat itself. Now, why would we want it to repeat? One example is to make sure the user input is correct. So you could ask the user input a number, say 1 through 4, and if they enter in -5, instead of just printing an error and being done, you would have it repeat over and over again until the user enters in a legal number. Now, some more examples. In advanced math classes, such as pre-calculus or calculus, we use summations to solve problems. We're actually going to use summations ourselves in some of the examples that we do below. Or maybe you need something to happen multiple times, such as you want to roll a die 10 times. For whatever reason, you want to roll it 10 times. So those are just some examples of how a loop might be used. But remember, loops are just tools, and they can be used in many different situations. So let's look at how we would print out a random number 10 times. So we want to roll a die 10 times. So before, we could write it once and then copy and paste that 9 other times, which is not terribly effective. So you can see I have int die, random number, print it out, create another random die, print it out, and I do that 10 times. Well, yeah, that works, technically, but not exactly the most efficient way to do it. Now imagine as if I had to roll 100 dice. Maybe I was doing some statistics and I wanted to see how many times a particular number came up. So I have to roll it 100, maybe 1,000, maybe 10,000 times. Well, you can imagine copying and pasting it would not be a very effective solution. So instead, we would use a for loop to solve this problem. Now let's review how a for loop works. And then we'll look at that explicit problem of creating a for loop to roll the 10 random dice. So a for loop, you have for, and then you've got 3 things inside of a for loop. What I call the start, stop, step. If you look online, you're going to see some other terminology utilized for these. But start, stop, step is a good way to think about it. So the start is just how you initialize a variable. And you're going to use that variable inside your for loop. The stop is a condition. And the condition, it's just something that's going to yield a Boolean value. And it's utilized to figure out when the loop will stop. So when your condition ends up being false, that's when the loop ends. And the step is how much the variable is going to change every single time the loop runs. So if we look at this example right below this, for int I equals 1, that's our start. So our variable is I, and we set it to 1. Now note, you can declare your variable right here in your for loop. Now when you leave the for loop, this variable will cease to exist. The scope of the variable is solely inside the for loop. So that's our start. Our stop is this condition, I is less than or equal to 10. So when that's false, the loop is going to stop. And this is our step, I++. So this is going to increase the value of I by 1 every single time this loop runs. Now note here that our stop, I is less than or equal to 10, sometimes if you write a bad loop, your start, I equals 1,
might not be true for your condition, and then your for loop will never run. So you want to make sure your starting value for your variable is true for your stop to make sure it runs. Because having a loop that doesn't run may not necessarily be the most useful thing. So this loop runs from 1 to 10, and it includes 10 because I is less than or equal to 10, going up by 1 every single time. And it prints off the value of I every single time. So it's going to print I equals 1, I equals 2, I equals 3, all the way to I equals 9, I equals 10. Now, I am going to do this I plus plus when I is 10, which will make I 11. 11 is no longer less than or equal to 10, thus the loop comes to an end. So let's roll those 10 dice we talked about earlier. But we're going to use a loop. So we have that same loop structure we just saw in that previous example. I is 1, I is less than or equal to 10, I plus plus. So I create my dice, set it to a random number 1 times 6, and I print it out. So that's going to roll 10 dice. Now, I gave in that theoretical example, what if I wanted to roll 100 dice? What if I wanted to roll 1,000 dice? Well, all I got to do is change that. Now it's rolling 100 dice. Now it's rolling 1,000 dice. Again, you can see that's a lot easier to manage than trying to copy and paste that same code 100 times or even 1,000 times. So let's do another example. Let's use loops to do summations. So you know in math class you've learned formulas to calculate summations relatively easily. But we can do this even easier utilizing loops. So I'm going to initialize a variable called sum. I'm going to set it to 0. I'm going to sum up the numbers 1 through 100. So my for loop goes from 1 to 100. And I increase sum by I every single time this runs. So that means I'm going to increase sum by 1, then by 2, then by 3, then by 4, all the way to 100. Now something to note here. A for loop only runs one line of code if there's no braces. So the sum plus equals I is part of the loop, but this print statement is not part of the loop. So this will quickly sum up 1 through 100. Let's try some different summations. Let's add up 1 through 100, but we're only going to do the even numbers. So 2 plus 4 plus 6 plus all the way to plus 98 plus 100. Now, I copied and pasted the exact same code that we had earlier, and we're going to modify it. Right now, this code does 1 through 100, but we want 2 through 100. So if I want 2 through 100, let's change our start. Change our starting value to 2 instead of 1. Now this is summing up 2 through 100. I want 2, 4, 6, 8. I'm going to change my step. I'm going to change my step to plus equals 2. So now, every single time I is increasing by 2. So I is now 2, 4, 6, 8. So when I increase sum, it's increasing it by 2, 4, 6, 8. Now, this is not the only way we could have done this. We could do this in another fashion. So I'm going to do the same thing. I'm going to copy paste this. I'm going to put it back to what it was originally. So this is 1 to 100 plus plus. Another way I could have done this is only add even numbers. So I'm going to use an if statement. So if I modulo 2 equals 0, that means it's even, I increase the sum by I. So now, even though my loop runs 1 to 100, I'm only increasing sum by I when I is even. So I